Have you ever felt that relentless drive to make things better? Not just okay, but really consistently excellent. Almost defect-free, maybe. Whether it's, optimizing a business process or streamlining a workflow, or even just aiming for perfection in something personal. It's a common challenge, isn't it? This sort of quest for reliable, high-quality results. What if there was a really structured, data-driven system, proven over decades, designed specifically to help organizations get to that near-perfect consistency? Today on the Deep Dive, that's exactly what we're doing. We're taking a deep dive into Six Sigma. Our mission really is to cut through the jargon, connect the dots between its core ideas, and give you a really clear understanding of its purpose. Where did it come from? What are the real benefits? And what are these frameworks that make it work so well? Ultimately, we want to show you how Six Sigma helps organizations make customers happy and, let's face it, boost their profits through just relentless operational excellence.
That's it, exactly. Six Sigma, it's way more than just a buzzword or some management fad. It's a systematic approach. I mean, it fundamentally reshaped how major industries actually operate and deliver value. We'll look at it from, well, three angles that connect: as a philosophy, a kind of guiding principle, then as a practical step-by-step process, and also as a precise statistical tool. Getting that holistic view is, I think, key to understanding why it's had such a lasting impact.
Okay, let's start right at the core then. The fundamental purpose, if we really boil it down, it seems to be about two things that are tied together: making customers happier and increasing profits. Is that too simple, or is that basically it?
No, that's actually a really powerful and, I'd say, accurate simplification. And it's important because Six Sigma isn't just about wishing for those things. It provides the mechanism, you see. It tangibly links delighting your customer directly to the bottom line. How? By getting rid of waste and variation. It's about building a system where, being excellent operationally just naturally leads to doing better in the market.
Right. And to really get the impact, we need to look at where it came from. Okay, picture Motorola. Mid-1980s. They're facing really intense global competition, right? And this huge demand for better quality in their electronics. They weren't just looking for, small tweaks. They needed a whole new way of thinking, a paradigm shift. And out of that pressure, in 1987, Six Sigma wasn't just, thought up. It was really forged. A radical, systematic approach to lift quality standards everywhere in their operations. And Motorola's success, well, it didn't go unnoticed. Industry giants quickly paid attention. Companies like GE, Dow Chemical, DuPont, Honeywell, Whirlpool, IBM, Kodak, they jumped on board pretty fast, adopted it, championed it. GE especially became famous for it. They integrated it so deeply they actually tied promotions and even profit sharing to Six Sigma training and project results. We saw Allied Signal get involved around 92, GE fully by 95. And by 2002, you had major players like Johnson & Johnson, Ford, Nissan all in. It really became the gold standard for operational excellence pretty quickly across all sorts of industries.
hmm And what's really interesting is why it caught on so widely. Six Sigma speaks directly to those challenges leaders always face, How do you keep customers happy when the market's always changing? How do you cut down cycle times, keep up with technology, retain your best people? And the big one, how do you reduce costs without sacrificing quality? Six Sigma actually helps retain people too. It empowers them, gives them the tools and permission, really, to find and fix problems in their own work. The benefits become really tangible. You see sustained success. Projects get picked based on customer needs and company strategy, and the results, the outcomes, they're tracked right against the financial reports. Companies put serious resources into it, full-time black belts, recognition programs, because the ROI, the return on investment, is just undeniable. You mentioned GE. Their own data back in the early 2000s showed something like over $2 billion in benefits by 2002. That dwarfed the costs of running the program.
Wow, okay, so it's definitely more than just a set of good ideas. What I find really compelling is how it weaves these things together. This philosophical commitment, a strict method, and this really ambitious statistical goal. It creates this whole system where each part strengthens the others. It drives not just smart changes, but a real shift in how organizations go after excellence. So as a philosophy, it's this idea that anything less than perfect is, an opportunity to improve.
Right.
It states pretty clearly defects cost money, not just rework, but lost trust, lost opportunities. And it says that really understanding your processes and then improving them is the best way to get results that last. Then as a process, it gives you that clear map. Define, measure, analyze, improve, control, tackle. DMAIC, we'll get into that. And finally, as statistics, it sets that incredibly high bar. Six Sigma processes should produce fewer than 3.4 defects per million opportunities. That number everyone quotes.
Yeah, and that 3.4 DPMO, It isn't just pulled out of thin air. This is a really crucial point. It actually accounts for something called a long-term shift of 1.5 sigma. It's a statistical tweak, basically, that admits real-world processes aren't perfectly stable. They drift. Things change over time. Six Sigma is pragmatic. It builds that drift right into its target. It makes it a tough but realistic goal for continuous improvement. And you don't get to that level by accident. It takes serious buy-in from management, leaders making big financial commitments, actively choosing projects that line up with the company's strategy.
Okay, and that brings us nicely to the core process Six Sigma is maybe most famous for, DMAIC. That five-phase method for improving processes that already exist. Let's break it down, because it really is a systematic journey. First up, define. This is where you nail down what's important here. You identify the customer, figure out their critical quality needs, the CTQs. You set a clear, smart objective for the project. Get your team together, define the budget, and capture the voice of the customer, really charting the course. Next, measure. This asks, okay, how are we actually doing right now? You have to make sure your measurement systems are reliable, that's key. Then you prepare a solid data collection plan and you meticulously gather that baseline data. Third, analyze. Now we dig deeper. We look past the symptoms to find the real, often hidden root causes of why performance isn't where it should be. You compare how you're doing now against benchmarks or the ideal state, always asking what's really wrong, not just patching things up. Fourth is improve. Okay, now we fix it. You present your recommendations, maybe run a pilot test to see if the changes work, then develop a full implementation plan.
And finally, control. This is all about making the game stick. Ensuring your improvements last for the long haul, guaranteeing performance doesn't just slip back to the old ways.
You know, that control phase, that's so often where improvement efforts kind of fall down, isn't it? It's maybe not the most glamorous step, but it's absolutely vital for making improvements last. The key question is, like you said, why bother with control if you've already improved things? And the answer is exactly what you highlighted. You have to embed the changes permanently, make them the new normal. And that means doing real things, updating policies, procedures, maybe engineering drawings, revising plans and budgets, doing the necessary training. It's about institutionalizing the better way. If you don't do that, improvements often just fade away, which is why Six Sigma really hammers home that point. Don't be too quick to declare victory.
Absolutely. Making it stick is everything. And, while DMAC is for fixing existing processes, it's worth mentioning its sibling, DMADV. Define, measure, analyze, design, and verify. People often call it Design for Six Sigma, or DFSS. And that's what you use when you're creating something totally new, a new product, a new process, a new service, building that Six Sigma quality in right from the start. Okay, let's switch gears a bit and learn some of the language. To really talk Six Sigma, you need the terminology. A really key concept, one that hits home for any business, is COPQ, the cost of poor quality. And this is broader than you might think. You've got your traditional quality costs, the easy-to-see stuff, things like inspections, warranty claims, scrap, rework, rejects, tangible, measurable. But then there are the hidden costs, often intangible, harder to measure, but, wow, potentially huge. Lost sales, damaged customer loyalty because of poor quality, long cycle times, missed opportunities, even something called the hidden factory, all the wasted effort fixing internal problems that customers never even see. On average, COPQ could be like 15% of a company's sales revenue. That's massive. And just to be clear, the costs of your raw materials, that's not COPQ. What's really powerful is seeing the link. As your Sigma level goes up, your cost of poor quality drops dramatically.
Right. And connecting to COPQ is understanding the basic idea of a process. In Six Sigma terms, a process is just, a series of steps or activities. It takes inputs, could be people, materials, information, whatever, and it transforms them to produce an output, a service, a product. This relationship is often shown really neatly with the equation y equals fx. Heard that one. So y is the output, the result you see, the effect, maybe the symptom you want to fix, and x represents the independent inputs, the causes, the underlying factors or problems, like if y is having a fever, then x might be the viral infection causing it. Six Sigma systematically tries to find and control those critical x's so you can get the y you want.
That YFX model, yeah, it really does simplify thinking about cause and effect, doesn't it? And speaking of getting the y you want, especially for customers, another vital term is CTQ, critical to quality. This basically means what matters most to the customer. These are the specific measurable characteristics of whatever you're producing, product, service, process, that are absolutely critical for customer satisfaction. Examples could be waiting time in a clinic, number of spelling mistakes in a letter, or maybe the percent of valves leaking during operation. The really crucial takeaway here is that Six Sigma projects, they are specifically designed to improve these CTQs. Six Sigma also draws a really important line between a defect and a defective unit. A defect is just anytime something doesn't meet a standard, like A scratch on a water bottle, that's a defect. The water bottle is only defective if that scratch actually matters to the customer, if it causes dissatisfaction. It's a subtle shift, maybe, but powerful. It moves the focus from just internal rules to what the customer actually experiences and values.
And that customer focus leads right into defect opportunities and DPMO. So defect opportunities are simply the number of chances within a unit or process where a CTQ could potentially fail, where something could go wrong. And the number of opportunities often goes up with complexity, right? Like your example, a unit has 5 parts. Each part has 3 potential failure points, maybe wrong size, wrong material, bad finish. That's 15 total defect opportunities for that one unit. Okay, then from there, we calculate DPMO, defects per million opportunities. This gives you a standard way to measure quality performance, regardless of complexity. You mentioned 13,333 DPMO being 3.7 sigma in that example, 2 defects found across 10 units, each with 15 opportunities. It seems like a bit of a leap, but it comes from statistical tables that link the DPMO rate to the sigma level, which represents how tightly your process is controlled. The simple idea. Fewer defects per million opportunities means a higher sigma level, a better, more predictable process, and the goal is at 3.4 DPMO.
That really drives home the kind of precision Six Sigma is aiming for. It's incredible. And a huge part of getting that precision is fighting variability. As, listeners who follow this stuff know, variability is like the enemy of consistency. Think about throwing darts. It's not just hitting the board, it's hitting near the bullseye consistently. If one player's darts are all clustered together, even if they're a bit off-center, they have less variability than someone whose darts are scattered all over, right? Six Sigma really is a war on that scatter, on variation. It uses standard deviation, represented by that Greek letter sigma, as the main tool to measure how much our process wobbles around its average or target. We all remember the normal bell curve, right? 68% of results fall within 1 standard deviation, or 1 sigma, 95% within 2, 99.7% within 3. Six Sigma aims way, way tighter than that.
Exactly. And when we tackle variability, we need to know what kind we're dealing with. We distinguish between common causes and special causes. Common causes. That's the natural random background noise in a process. The inherent variation you expect when a process is stable and predictable. Trying to tweak a process based on common cause variation, you will actually make things worse, increase the variation. Special causes, though, are different. They're non-random, unusual variations. They often show a pattern. You can usually assign them to a specific reason, and crucially, they're controllable. Fixing a special cause reduces variation, so knowing the difference tells you when to act and how. We also look at performance against limits. There are process or control limits. Those are statistical. They define the natural range of the process. Then there are specification limits. Those are set by the customer or engineering, defining what's acceptable. There's that analogy. A pilot who consistently lands within, say, half the width of the runway. That's like Six Sigma capability. Or parking your car perfectly centered within just 3 inches of the line when you have 6 inches of space on either side. That's hitting Six Sigma performance.
Okay, so we've gone through the numbers, the methods, the mechanics, but any system like this, it's only as good as the people involved, right? The people driving it. So what does all this mean for the teams actually doing the work? It seems to boil down to something often called people power. There's that great saying, tell me, I forget, show me, I remember, involve me, I understand. Six Sigma really builds that involvement through its structured belt system for training and assigning roles. Let's quickly run through these roles. Our audience is probably familiar, but it's good to recap. You start with yellow belts. They typically participate on project teams, support the efforts, usually alongside their regular job. Then you have green belts. They actually lead and deliver focused projects. They're like part-time Six Sigma change agents. Next up, black belts. These are the full-time leaders. They lead project teams, implement the methodology. It's usually a dedicated role for maybe 2 or 3 years. And at the top tier, you have master black belts. They mentor, train, and coach the black belts. They're the deep enterprise experts, usually permanent full-time change agents.
Right. And besides the belts, there are other crucial roles making it all work. The champion is absolutely vital. This is usually a senior manager or executive. They identify potential projects, they sponsor them, give direction, and maybe most importantly, they remove roadblocks. Organizational hurdles, cultural resistance, they act as a powerful advocate. And you also usually have a financial analyst involved. Their job is critical too. They validate the starting point, the baseline performance for a project, and then they verify the savings and sustained results after the project is done. Make sure the financial impact is real and accurately reported.
It sounds like setting up this whole belt system, it's not just about training people in statistics, is it? It feels more like fundamentally shifting the organization's culture, empowering people at all levels to actually solve problems. It's obviously a big investment, but Those financial benefits you mentioned earlier, they clearly suggest it pays off.
Oh, absolutely. It is about changing the culture. It's about empowerment, giving people not just the tools, but the authority to use data and make decisions. And
Yeah.
that empowerment is a huge driver for employee retention and engagement. It turns people from just, doing their job into active problem solvers. And
Yeah.
that directly fuels the program's success.
Okay, building on that, let's revisit those foundational principles. The core philosophy is Six Sigma that steers everything. It seems to be this constant, unwavering focus on four key things. First, know what's important to the customers, CTQ. Always start there. Second, reduce defects, DPMO. Drive that number down. Third, center around target, mean, beyond target, not just within spec. And fourth, reduce variation, standard deviation. Make the process consistent. These four pillars seem central. And to make that happen, you need certain critical elements in place within the organization. Things like a genuine focus on the customer, not just lip service. Data and fact-driven management decisions based on evidence, not gut feel. A strong process focus, understanding how work actually gets done. Proactive management, anticipating problems, not just reacting. Boundaryless collaboration teams working together across silos. And this interesting one, a drive for perfection, tolerance for failure, meaning aim high, but allow people to try things and learn from mistakes. That combination seems to create the right environment for this to really work.
That's a great summary of the environment needed. And that holistic view directly influences how Six Sigma projects get selected. Projects aren't just picked randomly or based on who shouts loudest. They're chosen quite rigorously. They listen to the voice of customer. Where are we falling short? What new things do they need? They look at the voice of market. What are the trends? Where is the industry going? Make sure the organization is adapting. And they consider the voice of competitor. Why are we behind in certain areas? What are they doing better? This strategic alignment ensures projects tackle the things that will have the biggest impact. So what actually qualifies as a Six Sigma project? There are usually three key criteria. One, there has to be a clear gap between current performance and the desired performance. Two, the cause of the problem isn't clearly understood. If you already know the cause, you might just need to fix it and not run a whole project. And three, the solution isn't predetermined. The optimal way forward shouldn't be obvious at the start. If you tick those boxes, you likely have a really good candidate for a Six Sigma project.
Expert, wow, we have covered a lot of ground today. From its start at Motorola and that core purpose mid-efficient, happier customers, better profits through the DMAIC steps, the key stats like DPMO and Sigma levels, the belt rolls, and that whole underlying philosophy of improvement, it's really clear, I think, that Six Sigma isn't just jargon. It's a seriously strategic approach. A powerful, systematic framework to get to operational excellence, make customers genuinely satisfied, and boost the bottom line in a way you can actually measure.
And to maybe broaden the view for you listening, this deep dive, it gives you a solid framework, a way to think about quality, efficiency, and continuous improvement, not just in giant corporations, but really in almost any situation. It fundamentally changes how you look at things. You start seeing processes everywhere. You start thinking about what really matters to the customer in that context, whether it's an actual customer, or a colleague, or even yourself. And you think about how to systematically cut down the variation, reduce the errors, the defects. It's about building a mindset of always optimizing.
Absolutely. A different way of seeing. So as you go about your day, maybe think about this. What process in your daily life, or at work, or even a hobby, could it benefit from figuring out its critical to quality elements, measuring its variability, maybe even applying a sort of mini DMAI cycle to reduce its own defects per million opportunities? You might just be surprised how much more consistently excellent your own results could become just by bringing a bit of this structured thinking to your own challenges.